So welcome to our second short video on the respiratory system. And the purpose of this video is actually to provide you with an overview and an introduction to spirometry, which is the technique that you'll be using in lab this week. Let me give you some references first. If you like the salad and text, this is the 8th edition that we're using in lecture. You might want to look at pages 863 to 867, and in particular, you might want to look at pages 865 to 867 for a really good discussion of spirometry. If you'd like to follow along in the lab manual, the WISE lab manual, you might look specifically at pages 470 to page 474. This is where they outline an activity that's pretty similar to what we'll be doing in the lab. And then also, if you like the OpenStax, I've put a link here, and the OpenStax discussion was actually pretty good. All right, so looking at the need to knows then, the purpose really of this short video is going to be to describe and define really mostly these four terms right here. I'll get back to forced expiration at the very end. But tidal volume, expiratory reserve volume, inspiratory reserve volume, and residual volume, these are all lung volumes that can be measured by the technique of spirometry, and then we can combine them in different ways to determine lung capacities. These are useful things to understand about a patient, particularly a patient who has lung disease, so asthma or COPD. So spirometry would be a technique that you will actually see clinically. All right, so let's look at this. The first thing that we'll talk about is what is a spirometer, and I'm going to show you two types of spirometers here. This first is actually a handheld or a dry spirometer, and I think it'll be clear why we describe it as being dry in just a second. More generally, a spirometer is an instrument that measures the volume of air that is inhaled or exhaled from the lungs. And this particular small instrument, you have a mouthpiece over here, a clean mouthpiece. The subject breathes into the spirometer through a clean mouthpiece, and then the gauge here on the top actually records the volume. And the volume actually is the air that goes in moves a turbine that's present inside the device, and this in turn moves the needle. And so you can actually read the volume of air right off of the face of the gauge. There's not a way to record from this, so you actually have to read it and then write it down separately. A dry spirometer or a handheld spirometer. The second major type of spirometer is a wet spirometer, and we're looking at one over here. There are some similarities. So first of all, you can see that this subject is blowing into the spirometer. He's got a clean mouthpiece here. He's blowing through this tube, and as he's blowing the air into the device here, he's blowing into an air chamber right here, and this air chamber is actually suspended in this tank of water, this small tank of water. So if we look at a diagram over here, we can see that as he blows air into the air chamber, then we displace the water that's in the air chamber, and that's going to cause this air chamber to move up and down, or to be displaced up and down in the tank of water. If we had a simple recording device, like a pen on a piece of paper, that was attached to this drum, as this drum is moving up and down inside the chamber of water, then we could actually see that the pen would be displaced on the piece of paper as well. So we could obtain a recording that showed the displacement of the air chamber drum here, and then we could further quantify that displacement to determine the volume of air that actually is going to be inhaled and exhaled. And obviously this is called a wet spirometer. This is called a wet spirometer because you're making these measurements in a small tank of water. Now, what would that look like? A recording that you got from an instrument like this? Well, we would call it a spirogram, and it would look something like this. So let me orient you to this figure, and I want you to imagine, first of all, that you are breathing into the spirometer. You're going to take some normal passive breaths first. Then you're going to inhale as much as you can, and then exhale rapidly, and then you're going to follow that again with some normal quiet breaths. So the trace that would be generated would actually be this red line right here. So this would be your normal quiet breath, your inhalation here, your exhalation right here, and then you would resume your normal quiet breathing. So you can think of this as being time kind of on the x-axis. going from right to left. And then on the y-axis, we actually have the volume of the lung. So this would be the volume of air that's present in the lung. So if we go back here at the start of our record, then you would breathe in and out very quietly. A maximal inhale would produce a maximum inhalation and a maximum volume inside the lung. The exhalation then decreases the volume of air in the lung to a minimum, but not absolute zero. And then you go back to your quiet breathing right here. So in and out very passively, very, very quietly. So we're actually going to start with this very quiet breathing here. This pattern, this very regular in and out that you see. The volume actually fluctuates between a pretty stable maximum and minimum that are not too far apart. We see this very regular in and out, and we call this volume here the volume of air that moves in and out during this passive, quiet, normal, at-rest breathing. We call this the tidal volume, And I always think of this as the tide goes in and out, the air goes in and out this way in a very regular, repeatable way. Now, the other volumes here, we have two volumes that we use, that we measure on the basis of the tidal volume. And the first is going to be this inspiratory reserve volume here. The inspiratory reserve volume is going to be that volume of air that can be inhaled on top of or after a very passive inhalation here. It's called a reserve because we can kind of tap into it if we have an increase in activity. Our expiratory reserve volume is pretty similar. This is going to be the amount of air that can be exhaled after a normal passive exhalation here. And again, it's also a reserve because we can kind of tap into it. So you can imagine that if you were exercising or running or doing something where you were breathing more forcefully, that your tidal volume would be more pronounced and it would be larger. So the inspiratory reserve volumes are volumes of air that you can kind of tap into. You can inhale more and you can exhale more if you need them. The residual volume is going to be this volume of air that remains in the lung following a forced exhalation, and it cannot be exhaled really under any circumstances. This is the amount of air that's always present in the lung. So we've talked now about, or I've introduced you to these 4 lung volumes, and these can be measured with spirometry. We have our tidal volume, inspiratory and expiratory reserve volumes, and residual volumes. Okay. Now additionally, over here on the right hand side, you see we have something called capacities. These lung capacities represent combinations of these volumes that we can measure with spirometry. So let's start with the inspiratory capacity. The inspiratory capacity is the amount of air that can be inhaled from a passive exhalation. So we can think of this then as being the maximum amount of air that can be inhaled following a passive exhalation here. We can also combine it mathematically. We can think of the inspiratory capacity as being thus the inspiratory reserve volume and the tidal volume, a simple mathematical sum of those two values. Okay, the functional residual capacity is going to be this capacity here. This would be the amount of air that's left in the lung following a passive exhale. So this then, again, would be, we could calculate it mathematically. We would say that the functional reserve capacity would be the expiratory reserve volume plus the residual volume here. The expiratory reserve volume and the residual volume. Our inspiratory and our functional residual capacity. The vital capacity is something that we do talk about clinically, and the vital capacity can be thought of as the maximum amount of air that can be brought in and exhaled from the lungs during one single respiratory cycle. Now, to calculate the vital capacity, you should be able to see that we can use our inspiratory reserve volume plus the tidal volume, plus the expiratory reserve volume. So we can combine these 3 volumes to calculate the vital capacity. But also remember that the vital capacity could be considered as the sum of the inspiratory capacity plus the expiratory reserve volume as well. So there's more than one way to make this calculation. The last capacity that we'll talk about is the total lung capacity. And this is really the volume of air, the maximum volume of air that can be present in the lung following a maximum inhalation. And the total lung capacity then would be the sum of all four of our lung volumes, the inspiratory reserve volume, the tidal volume, the expiratory reserve volume, and the residual volume. Or another way to think of this is that the total lung capacity would be the sum of the vital capacity plus the residual volume here, that volume of air that cannot be expelled from the lungs, no matter how forcefully you might try to exhale. All right, so I've created a table for you to kind of keep up with these here, and I've posted that on ELC, and you may find it useful to describe each of these volumes and each of these capacities in words and then also mathematically. And the author that we just saw on the previous page, as well as Saladin and Wise, they give you some typical volumes to give you an idea of about what those volumes should be, what those volumes and the capacities should be. So going back to our need to knows then, just to kind of wrap up, we talked about the four lung volumes, or the four respiratory volumes: tidal volume, expiratory and inspiratory reserve volume, and residual volume as well. Here is where I'll mention forced expiration. And this, just by definition, this is going to be exhalation that is forceful, that involves the use of the muscles of expiration to quickly expel air from the lungs. A forced expiration test or a forced expiration spirometry test would be something that would be used clinically in, say, a doctor's office or a nurse's office to look at the lung function of a patient, possibly a patient with COPD or even an athlete. So we have a couple of different ways. You might have an FEV1 or an FEV 1%, and you should be able to see normal healthy people have got a particular value. Something like 90% of the air that's present in their lungs should be exhaled within the first 10 seconds. And so the last thing that I have here is a video from YouTube that shows you the best way to do a lung function test clinically. I thought it was really, really useful. I thought it was very well done, and I thought it highlighted some of the things that would be important to know to get an accurate measure. So thanks for watching, and we'll see you in the lab.